We're going to continue on with volume, and we're going to find now the volume of cones, pyramids, and spheres. If you take a cylinder and a cone that have the same base, so I'm talking about this part right here, even though it's upside down, we're going to call that part the base. If those are the same size and the height of this cone and the height of this cylinder, if they're the same size, that means that the relationship between their volumes is we can take the volume of the cylinder and we can divide that by 3 to get the volume of the cone. Same thing with pyramids. If we have a rectangular based prism and its height is the same as this pyramid and the size of their base is the same area, we can take the volume of the prism and divide it by 3 and we get the volume of the pyramid. And same thing if it's a triangular based pyramid and a triangular based prism, if the heights are both the same and the base areas are both the same, we can take the prism and divide it by 3 and we get the volume of the pyramid. For our first example, we're going to find the volume of this square-based pyramid. And I look on my formula sheet and it says that my volume is the base squared times the height divided by 3. And my picture tells me that this is the B and this 12 is my height. So I just substitute those in. 10 squared times the height, which is 12, divided by 3. And I work that out. And I get that this is 400, and that will be centimeters cubed. This one is kind of a crazy drawing. It's actually a triangular based pyramid. So the gray part is on the bottom, and if you can picture there are 3 sides coming out of that. The important thing here that we need to know is that we are going to find the volume as if this was a triangular based prism. So the volume is the area of the base times the height, and then we're going to divide that by 3. So it's a triangle on the bottom. So the area of a triangle is base times height divided by 2. And then I'm going to times that by the big height, which is this guy. That's my big height. Divided by, I'm going to make that a capital just to show that it's different. Divided by 3. So my base, this is B, this is 6, times the height of the triangle, that's this one, that's 4. I'm going to divide that by 2, and then I multiply that by the height of the pyramid, which is 7. Turns out I didn't need these guys here at all, this 5 and this 5. And then I'm going to divide that by 3. So we're going to do the 6 times 4 first and divide that by 2. 6 times 4 is 24, divided by 2 is 12. So I have 12 times 7 divided by 3. 12 times 7 divided by 3 is equal to 28 meters cubed. This is a cone on its side, and the formula for a cone, you look on your formula sheet, is pi r squared h. This is nice. I know my radius, and the height, even though it's on its side, The height is 15. Oh, I forgot to put here that we have to divide that by 3. So we have pi times the radius is 8 squared times the height, which is 15, divided by 3. So my pi times 8 squared times 15 divided by 3 is equal to 1005.3, and that is millimeters cubed. To find the volume of a sphere, I have to go to my formula sheet. The volume of a sphere is 4 times pi times the radius cubed divided by 3. So on here, I'm going to make up a radius. I'm going to say that the radius of this is 6 centimeters. I'm going to substitute that in. 4 times pi times my radius is 6 centimeters, and that will be cubed divided by 3. Now on my calculator, I have to use Shift, and then I have a little x cubed button. You might be able to use a button on your calculator that looks like this, x to the exponent y. You could type in 6, then this button, and then 3, and hit equals, and that'll get you 6 cubed. Or you could just do 6 times 6 times 6. Or you might have a button that looks like a little arrow up. So you would go 6 to the exponent 3. Those are all options for using your calculator to calculate 6 cubed. So I'm going to do 4 times pi times 6, and then I'm going to use my to the exponent 3 button, and then divided by 3, and that is equal to 904. It says 0.77, so I'm going to round that up to 0.8, and that will be centimeters cubed.